Hello and welcome to Luckymath. In my last video up there I promised you that I'm going to introduce you to the so-called power rule for logarithms. And it goes as follows. Let's say we have the log to any base a of, let's say, the function x to the power r. Then this is equal to r times the log to this same base a of simply x. Now, as always, when we deal with logarithms, the base a has to be real, positive, and shouldn't equal 1. Also, the argument x should be real and positive, so greater than 0. And the exponent r can just be any real value. If you don't understand these conditions up here, you can check out the videos up there. Alright, let's do a very simple example for the beginning, so simple that we can actually check it. So suppose we had the log to base 2 of 2 to the power 3. Well, then according to this rule, this should be equal to 3 times the log to base 2 of 2. And I simply set r equal to 3 and took it in front of the logarithm. And now you know that the log to base 2 of 2 has to equal 1 because 2 to the power 1 equals 2. So this is simply 3 times 1, which equals 3. And now to check that the rule actually works for this example, let's just check directly, and let's see, this is the same as this because 2 to the power 3 equals 8. And you know that 2 to which power equals 8? Well, 3. So yes, the rule works for this example, and you're going to see at the end of the video when I'm going to prove the rule that it actually holds for all examples. Let's do another example. Suppose we had the log to base 3 of 1 over 9. Can we use this rule in order to calculate that problem? The answer is yes, because look at that. Isn't this exactly the same? By definition of the negative exponents, this is exactly the same. And now we can use the power rule in order to solve the problem and set r equal to -1. What we get is -1 times the log to base 3 of 9, and 3 to which power equals 9? 2. Therefore we get -1 times 2, which equals -2. Perfect. So yes, we can deal with such problems by help of the power rule. And I can write down the general rule for such problems. Suppose we have the log to base a of 1 over x. This is equal to the log to base a of x to the power -1. And this is just equal to -1 times the log to base a of x. And obviously this is minus the log to base a of x. So this is the rule that you're gonna remember. And there's another one. Suppose we had the log to base a of the nth root of x. Then this is equal to the log to base a of x to the power 1 over n, right? Simply by definition of the nth root. Because whenever somebody writes square root of x, then this is actually what is behind the square root is x to the power 1/2. Okay, so if you know this, you can apply the power rule again, and we take r equals 1 over n, so take it in front of the logarithm. We get 1 over n times the log to base a of x. Perfect. Okay, now the power rule really is an important rule because one of the aims of this playlist is to show you how to calculate derivatives such as, for example, of 2 to the power x. So you want to calculate that. And in order to do this, we're going to apply a trick, which is to rewrite 2 to the power x as e to the power ln of 2 to the power x. Don't worry, I didn't change the function. This is exactly the same because e and ln are their inverse functions, so this doesn't actually do anything to 2 to the power x. And now we can apply the product rule, not the product rule, the power rule, and we can take x in front of the logarithm. So we get that this is equal to e to the power x times ln of 2. And it will actually be much easier to calculate the derivative of that instead of directly of this. And as soon as I did a video on that, you're going to find it obviously up there. Okay, so finally let's prove the rule, and the proof is pretty easy, and I hope that this is enough space. Suppose we have this rule. So this is the rule that we want to prove. Then let's apply the trick and put both sides of it as an exponent of this base a. Then what we get is a to the power log to base a of x to the power r. And on the right hand side we get a to the power r times log to base a of x. Now, already in my last video, or one of my last videos up there on the proof of the power rule, I showed you that this doesn't do anything on the function. So these are their inverse functions, that's why that actually really crosses. What's left is x to the power r. And on this side, we can rewrite this actually as a to the power log to base a of x, and this whole thing to the power r. Remember, what hides behind this step is the rule x to the power n times m is equal to the power of x to the power n, and this again to the power m. So this is what I applied here. And now you again see that a to the power log to base a of x is again the same problem as here. So this doesn't do anything to x. Therefore we are left with x to the power r, since this is x. And now we've shown that both sides of the equation are equal, and therefore this rule actually holds. So we're done with the proof. Thanks for watching. Rate the video, subscribe. If you have any questions, write it in the comments, and see you soon again on Lucky Math.